Hello students, today we are going to explore something called the Pythagorean theorem. If you look at the picture to the right, I'd like you to see what's happening to the squares that are surrounding the side lengths A, B, and C. What we're going to do today is look at the relationship between the three side lengths of a right triangle in order to verify the Pythagorean theorem and also to apply it to finding missing side lengths and also to solve real-world problems. The first thing we're going to look at is the vocabulary. So you can see this green triangle on the left. There are three sides to a triangle. So the two side lengths that form the right angle, I want you to take a look at those. We've got two side lengths here that form the right angle. We're going to call this A, side length A, and side length B. Together you can see that they form a right angle. Those two side lengths are called legs. They are the legs of a right triangle. You'll notice that there is a third side here. This third side, you can see, is opposite the right angle. It's across from that right angle. It's not adjacent to it like A and B, the legs. And this side length that is across from the right angle has a special name. That name is hypotenuse. So the side length that is opposite the right angle is called the hypotenuse. And the variable that we often use for the hypotenuse is c. Now let's look how we can apply some things that we learned about the Pythagorean theorem to solve problems. Okay, let's look at this picture. Notice what you're seeing. You're seeing the side lengths A and B. And you're also seeing the hypotenuse C. You have squares surrounding the triangle. Let's think about what that picture shows us about right triangles. Let's first look at A. Let's get the value of A. A would be found, the side length, by looking how many units across the blue square is, and it's 4. So the side length of A is 4. The side length of B is going to be 3. And then the side length of C is 5. Okay? Now you can see from this equation, a squared plus b squared equals c squared, that we still have to square those side lengths. So let's do that now and see if this equation is true. First we'll start with A. A is 4. When we square A, you can look at the area of the square and you could see that the area is 16. So 4 squared is equal to 16. Now let's take a look at B. B, our side length was 3, so the area of the square that is adjacent to B is 9, because 3 squared is 9. Now let's look at that larger square that's adjacent to C. C, we know the side length is 5, but the area of the square that surrounds C is 25. Looking at the relationship between these three sides, we can see that when we square the side length of A, we square the side length of B. If we add them together, we get the square of the side length of C. This is called our Pythagorean theorem. It is only true for right triangles. So what does this mean and how can we use it? The first thing that we can do is we can determine whether side lengths form a right triangle just by knowing their lengths. So in this table, I have four different triangles, their lengths, the lengths of their legs and their hypotenuse. And using the Pythagorean theorem, we are going to check to see if these are indeed right triangles. I know that a squared plus b squared equals c squared. If this is a right triangle, if these are right triangles, then that must be true. So let's start with the first one. We have 2, 3, and 5. So I'm going to square 2. 2 squared is 4. 3 squared is 9. And 5 squared is 25. So now we're going to think, is 4 plus 9 25? Since it's not true, we can determine that this is not a right triangle. Let's look at the next example. For this one, the leg lengths are 3 and 4. Our hypotenuse is 5. So let's square each of the leg lengths, add them together, and see if it's equivalent to the square of the hypotenuse. 3 squared is 9. 4 squared is 16. 5 squared is 25. Okay? 9 plus 16 is equal to 25. This was just like the example that we saw on the last slide. So because this is true, we can say yes, this is indeed a right triangle. Now let's look at our next example. We have 6, 8, and 10. I'm going to square 6, which is 36. 8 squared is 64. And then I'm going to square 10. 10 squared is 10 times 10, which is 100. So now what we're trying to figure out is if 36 plus 64 is 100. Since 36 plus 64 is 100, we can determine, so we're going to put a check there. We should do that up here too. We can determine that the third triangle is indeed a right triangle. All right, let's look at the last triangle. For this triangle, there are side lengths of 9, 12, and 15. 9 squared is 81. 12 squared is 144. And 15 squared is 225. So now we're going to determine if 81 plus 144 is equivalent to 225. And it is. So this one is also a right triangle. So now we've seen how we can use the Pythagorean theorem to determine whether side lengths form a right triangle just by knowing their lengths. Our next question is, how can we find the missing hypotenuse of a right triangle? So we have two examples here, and we're going to learn how we can use that Pythagorean theorem to find a missing side length, and in this case, the missing hypotenuse. Let's start with our first example. We have our two legs, A and B, and then we have our hypotenuse, which we don't know. We're going to write down the formula for the Pythagorean theorem. A squared plus B squared equals C squared. We already know that this is a right triangle because we're given that right angle. A squared, that would be 5 squared. B squared would be 12 squared. And I don't know what C squared is. So I'm going to add the values of A squared and B squared together. 5 squared is 25. 12 squared is 144. And I don't know what C squared is. If I add 25 and 144, based on the Pythagorean theorem, that should be equivalent to C squared. (25) plus 144 is 169. So 169 is equal to C squared. But wait, I don't want to know what C squared is. I want to know what C is. So the way that we determine C is by finding the square root of 169. So I'm going to find the square root actually of both sides because we have an equation. The square root of 169 is 13. The square root of C squared is C. So now we can determine that the missing side length is 13 units. Let's look at the next example. Here we're given two side lengths that are the same. So our legs, A and B, have the same value. So I'm going to use my formula. A squared plus B squared equals C squared. I'm going to put in my two 8's to the formula. 8 squared plus 8 squared equals C squared. I know that 8 squared is 64. 64 plus 64 is C squared. If I add 64 and 64 together, I get 128. So I know that C squared is equal to 128. But what I'm trying to find here is C. So in order to do this, I'm going to find the square root of both sides. I know that the square root of C squared is C because C times C is C squared. For the next part, I'm going to find the square root of 128. And for this, I'm going to use my calculator. So I'm going to put 128 in my calculator. I'm going to highlight it, and I'm going to find, I'm just going to use that first. I put in my square root key, and I put in 128. And you can see that I get a decimal value of 11.3137. It's irrational, right? Because the square root of irrational numbers of non-perfect squares are irrational. So the square root, I'm going to round this to the nearest tenth, the square root of 128 is approximately 11.3 units. So I'm going to put that value here, 11.3. Okay, now we have looked at how we can use the Pythagorean theorem to determine if a triangle is right, and we also looked at how we find the missing hypotenuse. The next thing we're going to do, or the next question that we have, is how can we find a missing leg of a right triangle? So let's say we know the hypotenuse, but we are missing one of the legs. So if you look at our examples here, we're going to do the same thing as we did with the others, and we are going to use our formula. A squared plus B squared equals C squared. Now, if I'm trying to figure out which number is C, I have 3 and I have 7. Now remember, the hypotenuse is going to be opposite the right angle. So I know that C is 7 and B is 3. So now I'm going to plug in my values. What I don't know is a. So I'm going to leave that with a variable, a squared plus b squared equals c squared. I just wrote that. Let's back up. Let's go ahead and put in our values. A squared I don't know, but I know b squared. I can go ahead and square it here. B squared is 3 squared, which is 9. C squared would be 7 squared, which is 49. So I did skip a step here and I went ahead and squared the numbers. Now this time I need to find out a squared. I know that a squared plus 9 is 49, but I want to know what a squared is. So what I can do is I'm going to subtract 9 from both sides of my equation. When I do that, I get a squared is equal to 40. So now the last step is just like when we had the hypotenuse, we're going to have this find the square root of each side. The square root of a squared and the square root of 40. The square root of a squared is a, and now I'm going to find the square root of 40 using my calculator. So let's bring that in, and I'm going to type in square root key first, 40. The square root of 40, as you can see here, is approximately 6.3. So I'm going to write my solution, which is approximately 6.3 units. Okay, let's look at our next example. Again, we're going to use our formula a squared plus b squared equals c squared. A squared, 7. I'm going to go ahead and square it. 7 squared is 49. Just make sure you always remember to square it. A plus b is not equal to c. A squared plus b squared is equal to c squared. That's very important. I don't know b this time, so I don't know b squared. I do know c squared because I'm going to square 25. And I may need my calculator for this. So I'm going to bring in my calculator and I'm going to put in 25 squared. And you can see that our value here is 625. So I'm going to put 625 for c squared. Now, since I don't know b squared, but I want to find the value of b, I'm going to take 49 away from both sides. When I take 49 away from the left side, that cancels out, and I get b squared. And now I'm going to take 49 away from the right side. So I'm going to go to my next line, and I'm going to bring down that 625, and I'm going to subtract 49. We can see that it's 576, but remember, that doesn't mean that b is 576 units. What it means is b squared is 576 units. So I'm going to put in my 576, and I'm going to find the square root of both sides, like I've done before. I want to find out b, not b squared. The square root of b squared is b, and the square root of 576. I think I'm going to need my calculator again. So actually, I'm going to go to the next line. I'm going to click the square root key, and I'm going to bring down that 576. Oh look, it's a perfect square because the side length is a whole number. So the side length b is going to be equivalent to 24 units. So I'm going to write 24 as the value of b. So far we've learned how to find missing side lengths, legs, and the hypotenuse using the Pythagorean theorem. Next, what we're going to do is look at a real-life problem, and you're actually going to solve this one on your own. So our question is, how can we use what we learned about the Pythagorean theorem to solve real-world problems? Televisions are advertised by their diagonal length. So when you go to the store and you see televisions or you hear ads on TV or they pop up on your phone, you're going to see, especially this time of year, televisions on sale, maybe Black Friday. Coming up, we're going to have some deals, and you'll see that televisions are 35 inches, 75 inches, 60 inches. I want you guys to know something that not everybody knows is that televisions are advertised by their diagonal length. So in this problem, in this diagram here, I've given you the length of the television and the height or the width of the television, and you're going to use the Pythagorean theorem to determine the diagonal or the number of inches that this television is, because we advertise or we label our televisions by their diagonal length. And I want you to notice, I'll give you a little hint, each of these, this is a rectangle, so these are right angles. If this is 40 inches, remember, this is also 40 inches. All right. I've shown you today how we can use the Pythagorean theorem to find missing side lengths, and now you're going to try, or you are going to succeed at finding the diagonal length of using the Pythagorean theorem. You're going to find the diagonal length of this television.